Welcome back to Wickerson Studios. Michael Wickerson here, and I've been not producing any video tutorials as such for the last little while, and I've just been generating the scripts that might come in handy. And I've got a pretty interesting one here that I use Galapagos to optimize the volume of this form, but I want to show that it's actually driven by a kind of what you would normally do in a Grasshopper script. But actually, where did that go? There it is. Sorry, you do in a Numpy or Panda script over the Matplotlib library, but I thought I'd use the data into Grasshopper. So this is probably the first example of trying to wrap my head around that. It is object-oriented programming, and I do have a geometry here, and we can jump into it and have a look at that and how it's constructed from the initial ways I made a grid, and now I've added some functionality to it. And we'll go through that piece for piece, and we'll show how it operates here. So let's go back to the beginning. But before we go back to the very beginning of this, I did leave the number 4 script for you to figure out on your own. It's not a difficult one. There possibly is some visualization in here. Yeah, there's a couple of visualizations in here. If I took a look at it, I don't think my script is running currently. I have to. So whenever you come to a new script, and you'll see there's a bunch of here to load up, what you can do is just double click and grab the name and grab a new hops component. This is the best way to make it run. Don't try and get an existing node running. That's a bug in the program, but I don't mind dealing around it. Load it up and then just swap out your, I'm going to do a 4x4 array, and I'm going to have the LOC and the shape here, and then I'm able to take that geometry, and what I'm going to do is right click on there and pop in my name of my array and my call, and that's it. And then I'm going to plug it into the array list so we see what we're generating. And you'll see you're generating a pretty awkward little geometry. Oh, where am I going with it? You'll see that there it is. It's a pretty awkward little thing. And I basically stepped it up and made this little tower piece, which I thought was an interesting little, if I jump in here and go to artistic, it takes a while to run it, but you could bake that object out and get these kind of strange little towers. And you can also downsize how powerful you want it to be. But I'm using them as visuals on staircases and towers into Stable Diffusion. So I'm allowing myself a lot of freedom with that. And I'm generating a point system that is dependent on this node, which is the binomial array. And what I can do is show that down here, that it's generating a different binomial array as I go, as a 4x4 array, a 3D array, a list of lists, which generates the tree, and then that tree data is filtered through pretty simple line systems, lofting it up, moving it up, and then calling out the negative lines and lofting it together. So not too hard. When I say loft it up, I mean transform it up, move it up by a range, and then generate that outcome. And I think the other geometry I did was, let me get into this one. I'll take that one off. This one needs to be generated again, and this one's coming from the logistic. So once again, grab yourself a node when you come to these scripts, double click on it. I want to grab the name of that one, cancel that, open this one up, put it in and run it, and then just do the same, get rid of that. We're going to do a 4x4 to start columns, and it just needs a df value, and that'll generate other points. And those points, let me jump in here and grab my call function. You can grab it from Visual Studio Code or here. Okay, and this is that here under all the random. So I think this was the logistic binary I did before. Oh, sorry, this was the universal function. Before that, there's the log normal, there's the logistic, and that's the script for running that. Let's just go into here and add this. It's a little complicated to jump in here, but there's our geometries. We're going to generate a point system. We're going to move it up. We're going to put circles on one, circles on another, lock between it, and lock between those circles and cap it. So we get this strange little cityscape that can be as random as running your chi-square patterns. And there you go. And what I have done, you'll see, is I've left my cache on. And if I leave my cache on, I can go back to Oh, and we've got that other tower behind it, which is nice. Both are running. I can bring it right back to that pattern that I had before. And there is my strange little world that I could quickly grab both items, this one, and send them over to a bake. And I don't think the bake would take too long. And there you go. And you can leave one on or the other one on. It wouldn't matter. You've got a pretty nice little scape to start bringing in the stable diffusion. And with that simple model, which is driven by data, which can be manipulated as a multi-dimensional array very fast, you can bypass all that crazy tree operations, data tree operations you were trying to do. And this entire file is based on random number generators. So you've got the random module, you have the seeds, you have the permutation, you have the shuffle, you have the uniform, you have the integers, and that's basically scripted here all for you and brought us up to about 2,800 lines of code. And then I left that and said, okay, that's enough of that. Let's leave this and go into here. And I've got a couple of baked objects here that I have to get rid of, or I could hide them. And you'll see I have this strange little geometry here. And you're like, what is going on with this? I thought this was fun because I'm actually optimizing this space for mass volume. And I'm generating that by evaluating surfaces to get that full size. And instead of me sliding around and trying to find the full volume on these two interfacing curves that start intersecting surfaces, I just use the gene pool. So over here, I optimized, you just click on here, you can set your, I think you can right click and then collect all sliders, but I don't want every slider. I just wanted the 4 that were sliding around on the surface of 2 reparameterized surfaces. And then with the union between them, depending on what happens, if I get the numbers right, there'll be a union. If I don't get the numbers right, there won't be a union, but that's why I'm using Galapagos. So let's just come down here and try and get a union. We'll see it go blue. There we go. And we have a certain volume to that union. And at that point, it gives me a center, it gives me a volume scale, size, which we can look at. But I'm trying to get that as high as possible. And of course, Galapagos does that for, excuse me. So without further ado, I went in here, and before I modeled this thing, I thought it would be best to talk a little bit about what universal functions are. And the universal functions, everybody knows, are the unary functions and the binary functions. And those are things that come pretty common with any scripting coding. And so the first ones are square root, and I think there's an example of expression, exponent. And then there's binary universal functions, U functions, which are things like add, subtract. And I chose the one that would be the binary one that I chose to do down here after binary function was maximum. So I go maximum or minimum. So when I run these two, you'll see these lists, 2 lists will pull up the top one. Once again, when you come live to my script, you will have to go in here. You will have to reset this. They will not just run for you. You have to call them from where you're calling them. And that's enough to get those 2 points in there. And let's pop that one in as the first series and that as the second series. And this will find the maximum of both series as it goes down the list. Now there's other unary function and binary functions within Grasshopper vanilla tools. So you don't really have to spend a lot of time on this. And I did not spend a lot of time on this. And I'm not very excited about them because they're of course 1D arrays. And that doesn't excite me at all. So let's go in here and paste the name in, and now we've got it working. And then the one that I thought was very nice here was, this was a cool node, and this came after the binary functions. It's a really nice mod F, which gives you a remainder and a whole part of numbers. I thought that was a pretty cool function that could run on, it's starting on a 1D array, but you can extend that to more arrays. So I really like that tool. And we're going to jump in here. I'm just taking a look at an email. I think we're live. How long have we been live? Oh, we have somebody watching us. That's fine. I put everything. If I do have somebody, I'm going to plug like where all my stuff is. And everything right now is currently at wickersonstudios.com in the chat. And you can see that I'm just getting rid of everything. And I'll be adding these next 2 bundles to the all-in-one bundle, and then these will be separately packaged into like $1.99 bundles. Just trying to get people out there to see which ones are popular And all the old work all the way back to 2019 is there as well. So let's just continue with this. What was I talking about? I was trying to modify this one, so I've got to come new with a node. I thought I copied that, cancel that, put it into the path, throw it in there. It's not a very hard one. You probably don't need to put the call in here. And there's one that will take the whole numbers. Oh, those are the remainders, because that's the way I scripted it. And those are the whole numbers. So there you go. You bust your number into two awesome parts, and it's a fast moving, it's a very fast moving operation. But once again, 1D arrays don't excite me too much. So let's not get too excited about them. There they are. So let's jump into, I kind of put those over here, and I'm just going to put them into a kind of a passive green color. I think I'll just ungroup, I'm not even worried about it. So what you want to do is get into object-oriented, array-oriented programming, and that's going to bring us down past, and those are the other things you could do. I'm sorry to get ahead of myself. If you're going to sit here and do these, why don't you just write the function themselves? And if you have GitHub Copilot, they're not hard to build. Like if I just wanted to go in here and say, let's get a abs unary function, a u function. Let's just tap this in. Well, let's prime it with I want the abs function, and then I want that into Grasshopper script. And that means I may not be online. I am. What is going wrong with GitHub Copilot? Did I fuse out? Come on, Copilot. No, I lost my Copilot for a second. Give me a second to find out why that's not running for me. It's not going to do me any good if it's not going. I mean, you could write the function. It takes forever to sit here and type in all this stuff and then modify it. But you could go in and write down all this stuff again, change all the names, get all your typos, and that's really why you want to speed things up with Copilot. But I'm curious as to why. And I did have to restart my computer earlier. So very strange. Copilot, blah, blah, blah. Have to reinstall any of this stuff. I hope not. Angular Copilot, Copilot Genie. Player Copilot, Visual Studios. Oh, that's weird. Sometimes it cuts that on me, but I couldn't tell you why it's doing it today. And it's usually down here at the bottom. But I guess my Copilot has decided to hate me for a minute. Well, since I don't really need it, I could fudge through all those if I wanted to. But I'm not really coding right now, so I'll just leave it. I'll figure it out at a later date why that's not running for me. But you could sit here and you could write all from scratch your hops components. And what I would suggest, all you're going to end up doing is cutting and pasting these things, the hops component, and it still will have some intelligence for you. So you're going to want to jump down here, and then you're going to have to put in the name and all that other stuff. So I'm just going to leave that and let people make as many unary or binary ones they want. Here's a list of binary ones after, and you can add them to the script if you want. But like I said, I'm not going to bother because I don't really care to use them that much. So what I did was we'll just move this one aside because we'll get to this geometry in a minute. Array-oriented programming with arrays express many data processing tasks and concise array expressions, and you're using vectorization. And I've got out of a textbook a couple of examples of how it works right down in my terminal window if I want to run that. And it shows how you can pull, elements of each one in the rows, and we're trying to build a kind of a mesh grid. This produces a mesh grid for possibly going in the matplot library. However, I'm not interested in matplot library. I'm interested in taking that logic and putting it into something like this. So if I run this first one, and I think I'll have to go into my early data visualization over here, but what I started with was, that was I keep going back to it. You're going to start with it, and I'm going to generate a script here. Let's go to the first mesh grid I generated, And we're stuck doing this again, which is a little bit of tediousness, but this is just the nature of it. You'll have to do it as well. Copy that. You can get rid of that. You can slide that up there and you can just paste it in and run it. And that will get it up and going. Those are your points. Those are your Y points, XS points, and those are your Y points. And that's going to give you data to a certain point. Let's take the mesh grids copy and give it its name. It's quicker than doing an icon. Unless you have an icon, you could always plug the icon in there. It'll pop up automatically. It comes right after the description. There's an icon thing that you can type in here. But since I don't have any icon planned, I'm not going to bother putting one in. There's an example in there from the first script that's in this entire script from Rhino Compute. And so you can go in there and do that. So you've got your data to do that. But that's not doing anything. That's just giving me data. Look, it's giving me strings. And I don't want strings. I'm going to get into data frames and pandas and play around with that a little bit. But what I want to do is go down and turn them into numbers. And then I want to use them as arrays. And I want to pull them out as arrays, rows of 10 rows. So this is a better example of it. It's going to be quite a little bit of a hookup here. And this is a pain in the butt because you have to work around this. We're going to copy that. Okay, we're going to get rid of that. We're going to put our script in. We're going to take our start. We're going to take our stop. We're going to take our step. And we're going to file this all in. And we're going to watch this kind of grow as a 4-piece as we go. And I think I'll skip Visual Studio Code because I want to show what you're actually visualizing this data. So as we go through, I think I could probably see this have effects. But let's just plug it in first. There we go. You see the lines coming across the bottom here. And they're coming across in a very boring pattern because they're just numbers and they're linear and they're gridded out, I think, by just a grafting tool. And then you get that surface when you're done. You put them all together, and they all go into this surface. That's not too exciting. So just one little step down, you'll see that I wrote it again, but this time I did the multiplication of what was required. So x squared plus y squared, and that'll give me the square root of that. So I plugged that in, use that in the language here, output all of those things, all of those lists from that array, and with that I was able to generate, and we probably don't want this data visualization on, you'll see that I was able to generate these points. They come in rows and they kind of come forward and then back, so when I lift them up they form this surface, so they actually become these lines as you move them up in the z direction. I'm moving them up by a series of 10. So you kind of have to think about your geometry and what you're going to need. And as I have that, I'm going to analyze the surface on there. Oh, I'm going to optimize so I can just mirror. That's all I did was I mirrored the object right here. And then I evaluated the surface to both points so that they would then overlap. I grabbed a Boolean union and then I have a centroid and a volume. So I have Galapagos, and here's the fun part. You can sit here, and we're going to go on farther on the script because there's plenty more things to do with NumPy, where, and conditionals. We've got other things to finish off, and I'm going to keep this series till we're almost done. And we might build a pie chart or something more exciting than a linear chart. But let's just double click on here, and we want to give it a second. It takes a second for Galapagos to open the first time on something. And we're nearly done here. Give it 1 second. There we go. Your solvers are here. My solvers are set for all solutions. My options, I want to set enable from 0. I just want to go 2 minutes. I have a tolerance that will get close and then stop once the tolerance gets within there. I think I'm going to send the tolerance a little longer. And that's the threshold. Go back to the solver and let's hit start. And you'll see this is optimizing to find the biggest space as that comes together. This is a pretty nice thing. It's analyzing everything, and here it goes. It'll go for 2 minutes, or I can shut it off. I can stop the solver anytime. But it's generating us some volumes that are up to 45 cubic units. Almost 46 cubic units. And you just keep going. It's kind of getting slowed down, and I think we found it. 46 is our big one. So the solver stop. We're going to reinstate as it hit threshold. I'm going to reinstate this one. And if we didn't want that 45, we'll probably find another one with as much volume up there. And we have one that's 44 right here. As soon as you have the one you like, you can hit close. You can go back to this form. You can bake that. And now you have your first geometry that is kind of interesting, generated for the volume of that. So that's a little bit of an example of how we'll use Galapagos, but tie that back to using something that's data, and instead of producing a nice simple x squared plus y squared square root of that function as a matplotlib visualization, I can abstract things into something as complicated as this, because that's just how my mind has fun. And if you had a reason for it, or you want to do something creative with it, then go ahead. Or if you needed to build something functional, then you don't have to follow other parameters. I really don't have any expectations to follow any parameters besides being creative with these tools. So that is it. I'm going to end my stream. I think I'm going to end my stream and end my recording and put this online. So we will stop the recording.